Hi viewers, today we want to discuss about motion in a straight line. So first we should know about rest and motion, distance and displacement, speed, velocity, acceleration and acceleration due to gravity, equations of motion in straight line, and also freely falling body and vertically projected up body. Now first we go for the what is meant by rest and motion. So we all of us know that what is rest. Rest is nothing but the body is said to be at rest if it does not change its position with respect to time and surroundings is called the rest. So if we keep a pen on the table, it will be at rest if you don't disturb it. And what is meant by motion? So motion is nothing but, you say that the body is said to be in motion if it changes its position with respect to time and surroundings. So a fan moving in a room or a man is moving, they're all nothing but we call it as a motion. It is said to be motion. So these two are relative to each other. So rest and motion are relative to each other. So we have a best example, that is when you are going in a train. So we are at rest, sitting in the compartment. But for a person observing from the outside, so we are in motion. Therefore, rest and motion are relative to each other. So now, the second important point in this what we call this motion in straight line is distance. So distance is nothing but the actual path. So distance is the actual path covered by a body. So actual path covered by a body is called distance, actual path. So a body is starting from A and reaches B. Then the actual path covered by the body is called as a distance. So AB is nothing but we call it as distance. So say 10 centimeters. So distance will be equal to 10 centimeters. So now this distance is a scalar quantity. It does not have any direction. So it is taken to be a scalar. Now if you go for the next one, that is displacement. So displacement is nothing but the shortest distance or shortest path covered by a body. By a body, or the initial distance between the, or the distance between the initial and final positions of the body is nothing but we call it as displacement. For example, the body starts from A and moves to B. From there it goes to C. Now the shortest path is AC. So AC is nothing but it gives the displacement of the body. So AC is a displacement. And we have AB plus BC is distance. Distance traveled by the body. Okay. And this displacement is a vector quantity, whereas distance is a scalar point. Now, when we have an idea about distance and displacement, now we go for what is speed. So speed is nothing but distance by time. So distance travelled per unit time is called as a speed, and its unit is a meter per second, and it is a scalar term. And if you go for the velocity, so velocity is a ratio of displacement by time. Is nothing but we call it as velocity. Displacement by time is velocity. So it has the same unit, meter per second, and it is a vector point. So when we have an idea about speed and velocity, now we go for the what is meant by acceleration. So acceleration is nothing but rate of change of velocity, acceleration. So it is denoted by A. So A is equal to formula, we can write V minus U by T, where U is the initial velocity, V is the final velocity, T is the time taken. And its SI unit is meter per second square. And it is a vector point. So now, when we know the acceleration, now we go for the one of the important things, that is acceleration due to gravity. So it is denoted by small g, acceleration due to gravity. So the acceleration possessed by a body toward the center of the earth or due to the earth's gravity is called as acceleration due to gravity. So this acceleration due to gravity, g will be, it is equal to 9.8 meters per second square. We take it as a standard value. But g changes from place to place, and there are so many factors we will discuss in the other topic. So when we know these things, that is acceleration and acceleration due to gravity, now we have the equations of motion. So basically we have equations of motion. First we are taking along a straight line. That is linear motion. So we have the four equations. V is equal to U plus AT. S is equal to UT plus half AT square. Third one, V square minus U square is equal to 2AS. And the fourth one, Sn is equal to U plus A into N minus half. So they have the regular meaning, that is terms. U is initial velocity, V is the final velocity, A is the uniform acceleration, S is the displacement, and T is the time taken. Now these are the equations of motion in case of a body moving along a straight line. And if you go for the freely falling body, so when we go for a freely falling body, that is, when a body falls freely, then we have the conditions. U is equal to 0, A is equal to plus G, and V is equal to V, S is equal to H. So if you substitute these values in the above equations, then we have V is equal to V. So therefore, V is equal to U is 0 plus in place of A, G. So V is equal to GT is the first equation. Similarly, we have the second equation. That is, the second equation is S is equal to UT plus half AT square. In place of S, you can write H. H is equal to 0 plus half GT square, or H is equal to half GT square. This is the second equation. And third one, V square minus 0 square is equal to 2GH. or V is equal to root 2gh. This is the third equation. And fourth one, we have Hn is equal to 0 plus g into n minus half, or Hn is equal to g into n minus half. These are all fourth equation. These four are called as equations of motion in case of a freely falling body. Now, when we know that is one is straight line, second one is a freely falling body. Now we go for the vertically projected upward. That is, the body is thrown vertically upwards. So vertically upwards. So vertically upwards. Then we have the conditions: u is equal to u, a is equal to minus g, b is equal to 0, s is equal to h. So we are talking at the highest point. So highest point we are taking. Then v becomes 0. Then we have four equations. First one, v is equal to 0. 0 is equal to u minus gv, or u is equal to g. This is the first equation. Second one, h is equal to ut minus half g square. And third one, v square, 0 square minus u square is equal to minus 2gh, or u square is equal to 2gh. Next, fourth one, we have Hn is equal to u minus g into n minus half. So these four are the other four equations in case of vertically projected up body. So in this video, I have discussed about what is rest and motion, and also speed and velocity, distance and displacement, acceleration and acceleration due to gravity, and equations of motion in case of along a straight line, in case of a freely falling body, and vertically projected body. In the next video, we will discuss about the other part of the motion in a straight line. Thank you for watching my video. Please subscribe Physics DSR.